Good morning, friends. Today we'll continue our topic, that is volume of cube, cuboid and the cylinder. Yes. So we'll move on to exercise 11.4. That exercise was given to you for homework. Now we'll solve the sums to see if you have done the sums correctly. Kindly compare your solution with mine. Now question number 1 has given a cylindrical tank. In which situation will you find surface area and in which situation volume? So first question is to find how much it can hold. So that is the capacity. So we have to find the volume. Number of cement bags required to plaster it. To plaster the tank, we plaster from the outside on the surface. So we'll find the surface area. To find the number of smaller tanks that will be filled with water from it. For that purpose, we need to find the volume of the tank and the smaller tank. So that was a theoretical question. Now we'll move on to the sums. So take out your rough book where you have done the homework and compare your solutions with mine. So this is the theme of the topic, volume of three-dimensional objects, the cuboid, the cube and the cylinder. I hope by now you have learnt the formula of all three very well. So we can move on to the sums. The second sum in exercise 11.4 has got this. Diameter of cylinder A is 7 centimeter. So the diameter of cylinder A is 7 centimeter and its height h is 14 centimeter. So let me write in cylinder A the diameter. Let me write A below here. Diameter A is 7 centimeter. So the radius of cylinder A, RA let me call it, will be 7 by 2 because the radius is half of the diameter. And the height of the cylinder A is given as 14 centimeter. So this is the information given to us regarding the cylinder A. And similarly, diameter of cylinder B is 14 centimeter. So you can see the orientations have changed. Diameter of cylinder B is 14 centimeter. So the radius of cylinder B is 14 by 2 or 7 centimeter and the height of the cylinder B is 7 centimeter. So you can see in this sum we are given the diameter and not the radius. So we have to find the radius. Now without doing any calculations, can you suggest whose volume is greater? So this is just a mental theoretical question without doing any calculations. Can you suggest whose volume is greater? So first you suggest and then we'll verify by finding the volume of both. Now, how do we do that? So, we'll first recall the volume of the cylinder is given by pi r square h. So what you can see here, pi is a constant. We have to take the square of the radius and the height. Now here the radius, compare the radius. The radius is half here. The radius is 7 here and 7 by 2 means the radius of B is double of the radius of A. And you can see the height here of A is double of B. So both have been interchanged here. The radius of cylinder B is twice the radius of cylinder A, but the height of cylinder A is twice the height of cylinder B. So if you compare this, what will you get? You can see this r square. So any guesses which has got a greater volume? Now we'll do the calculation and then compare our answers. So volume of cylinder A will be pi, that is 22 by 7 into RA square, that is 7 by 2 into 7 by 2 into the height which is 14. So we have 7 and 7 cuts, 2 ones are, 2 sevens are, 2 ones are, 2 elevens are. So we have got 11 into 7, 77 and 77 into 7 will give us 7 sevens are 49 and 4, 7 sevens are 49, 539. So here we get 539 centimeter cube. Now the volume of B will be 22 by 7 into radius B, that is 7 into 7 into height, which is 7. So 7 and 7 get cut. So left with 7 sevens are 49 into 22. 49 into 22. So 0, 2 9 is the 18, 8 carry 1. 2 4s are 8 and 1 9. 2 9s are 8 carry 1. 2 4s 8 and 1 9. So we have got 8, 9 and 8 17, 1078. So you can see volume B has got a greater volume. Now we check the surface area to see whether the surface area of both is same or not. So CSA of A is 2 pi Rn. So 2 into 22 by 7 into R, that is 7 by 2, into H, that is 14. So 7 and 7 get cut, 2 and 2 get cut. So surface area is 14 into 22. Let us calculate 22 into 14. 0, 2, 2, 8, 8. You got 803. We have got 308 centimeter square. Okay, but we have found the CSA. They have not mentioned the surface area. So I think we should go for the total surface area. So let us not do the CSA, but let us find the TSA. Because they haven't mentioned what to find, so we'll go with the TSA, the total surface area. So we have TSA of A will be 2 pi R bracket H plus R, that is 2 into 22 by 7 into 7 upon 2 plus 14 plus 7 upon 2. So 7 and 7 get cut, 2 and 2 get cut, so left with 22 into bracket 14 2s are 28, 28 plus 7 35 upon 2, 2 1s are 2 11s are, so 35 into 11 will give us 385 centimeter square. That is the surface area of A. The TSA of B will be again 2 into 22 by 7 into 7R into 7 plus 7, that is R plus H. So 7 and 7 get cut. So 2 22s are 44. 44 into 7 plus 7 is 14. So we have 44 into 14, that is 440 plus 176, that is 616 centimeter square. So in this sum you can see the volume of B is greater than volume of A, and even the total surface area of B is greater than total surface area of A. So in this sum, the one with the greater volume has the greater surface area. I hope this sum is clear to you. If not, you can rewind the video and see it once more. Now in the third sum we have, find the height of a cuboid whose base is 180 centimeter square and volume is 900 centimeter square. We have done this sum before, but you can still quickly revise it once. Volume of a cuboid is given as L into B into H. Okay, volume is given 900. Now L into B is not given, but the area of the base is given 180. So instead of L into B, we will take 180 into H. So 180 goes in division. So 900 upon 180 should give us the H. 0 0 cut, 18 ones are 18 5s are. So H is equal to 5 centimeter. That will be the height of the cuboid. Using the simple formula, we get the answer very quickly. The next sum we have a cuboid whose dimensions are 60 by 54 by 30. How many small cubes with side 6 cm can be placed in the given cuboid? So we have a big cuboid whose dimensions are given 60 cm length, 54 cm breadth and 30 cm height. In this we have to place small cubes of 6 by 6 by 6. So how many cubes can be placed? So you can see, suppose I start filling it with the cubes. Okay, let us say total number of n cubes fill up this cuboid. So n into volume of cube, because one cube has got a volume 6 by 6 by 6, 6 by 6 by 6. So when I take n number of cubes, the total volume of those all the cubes together will fill up the cuboid, will give me volume of cuboid. So n, which is the number of cubes, can be found out by finding volume of cuboid, and this is in multiplication. Cube will go in division upon volume of cube. So volume of cuboid is given the form L into B into H, and volume of the cube I will write capital L, L into L into L. So the length and breadth and height of the cuboid is given as 60 into 54 into 30, and of the cube is given as 6 into 6 into 6. So I got 6 ones are 6 tens are 6 ones are 6 nines are 6 ones are 6 fives are. So 10 fives are 50, or 9 fives are 45, and 45 to 10 is 450. So 450 cubes of dimension 6 by 6 by 6 can be filled into this larger cuboid. So just by using the formula, we can very easily do the sum. Yes, I hope this sum is now clear to you. The next question we have, find the height of the cylinder whose volume is 1.5 meter cube and diameter of the base is 140 centimeter. So first I draw a cylinder, and you have to pay attention to two things here. The diameter of the base is given 140 centimeter. So the radius will be half of the diameter. So first we'll write diameter is 140 centimeter. So the radius will be half of it, 70 centimeter. Now the diameter is given in centimeter, the volume is given in meter cube. Volume is 1.54 meter cube. So to solve this sum, we'll either convert the centimeter into meter or the meter cube into centimeter cube. Now we know 1 meter cube is 10 lakh centimeter cube. In the previous video, I explained to you how we get this. So 1.5 meter cube will be 1, 2 decimals, so I cut off 2 zeros here. So I get 1540000 centimeter cube. Now directly by using the formula, volume of cylinder equal to pi r square h. So we have to find out the height. So I will first put down the values. Volume is given 1540000 equal to pi is 22 by 7 into r. R is 70. So 70 into 70 into h. Now since I have to find out the h, the 7 which is in division, I will take in multiplication, and all the numbers in multiplication I will take in division. So 1540000 into 7 upon 22 into 70 into 70 should give me the h. So first I cut off the 2 zeros, 1 7 gets cut, 7 ones are 7, 22s are 0, 0 we got, and 22 and 22 we get cut, so 100. So height of the cylinder is 100 centimeter. And now if you want to convert it into meter, you can write 1 meter. So the height of the cylinder will be 1 meter. So this sum is also very simple, but the only thing you have to see is the volume is given meter cube and the base is given in centimeter, diameter is given in centimeter. So here you will have to convert before you can solve the sum. In the next sum we have a milk tank is in the form of a cylinder whose radius is 1.5 meter, length is 7 meter. So we'll write radius is 1.5 meter and height is 7 meter. Sorry, not centimeter, it's meter. Question asked is find the quantity of milk in liters. So we have to find in liters the capacity. So first we'll find the volume and then we'll convert the volume into liters. So we'll first find the volume of the cylinder, again by the formula pi r square h, that is 22 by 7. R is 1.5, so I'll write 15 upon 10 into 15 upon 10 into height. Height is 7. So I will cut this 7 and 7. 15, 15 is 225. 225 into 22 will give me 0, 0, 5, 9, 4. 4950 divided by 100 will give us 49.50 meter cube, since it is in meter. Now we have to find it in liters. So I hope from the previous video you know the conversion rule. 1 meter cube is 1000 liters. If you have not followed how this works, then go to the previous video and see the video on volume and capacity where you will find this formula. So 49.50 into 1000 will give us 4950, then 3 zeros and 2 after decimal point, so 2 zeros will cut off. So we get 49,500 liters of milk can be stored in such a cylindrical tank. Okay, now this is a very interesting sum. We have done this type of question. Let us do it again. If each edge of a cube is doubled, how many times will its surface area increase? How many times will its volume increase? So first of all, they have not given us any measure. So what will I do is, first I will take a cube whose sides are S, S, S or X, 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 whatever you want to take. Let us go with X. So let us write, let the side of the cube be X. So the total surface area of the cube is 6x square and the volume of the cube is x cube. This we get from the direct formula. So this is the original. Okay, these are both are the original. Now we move to the comparison, which we should get after we double the edge. Now when we double the edge, you will see what do we get. We put a edge here, so the length is doubled. It has become 2x. In the same way, this edge is also doubled, so this also becomes 2x. And we have put one on the top, which doubles this also, so the height has become 2x. What have they mentioned here? If each edge of the cube is doubled, so you double the edge, which is the length, becomes 2x, the breadth becomes 2x, and the height. For that you will need how many cubes now? Can you guess it? We will need 8 such cubes. Yes, we will need 8 cubes to double each. So the length has become 2x. So now we have, so you will see this forms a cube again. So now the side of each cube is 2x. So now the total surface area of the new cube is 6 into 2x square. So that becomes 6 into 2 square is 4 into x square. So it becomes 24x square. And the volume is 2x the whole cube, which becomes 2 cube, that is 8, into x cube becomes x cube. So we have to find how many times will its surface area increase. So original was 6x square, now it has become 24x square. So take the ratio 24x square upon 6x square. X square cut, 6 ones are 6 fours are. So the total surface area is increased by 4 times. And the volume, the new volume is 8x cube. Initial volume was x cube. You cut it off, you get 8. So the volume has increased 8 times. So when you double the edges, what will you see? That the surface area increases 4 times and the volume increases 8 times. So and how do you get this? Since you doubled it, since we doubled it means made it 2 times, the area is given in x square, so 2 square will be 4. The volume is given in cube, so 2 cube will be 8. So this way also you can remember how the things are changing. For the last sum we have, water is pouring in a cuboidal reservoir. You can see this diagram, the reservoir, water is pouring into it at the rate of 60 liters per minute. So we need to write it down, 60 liters per minute, that is 60 seconds. If the volume of the reservoir is 108 meter cube, find the number of hours it will take. Now this is the total volume. So first we'll convert this volume into liters. So we know 1 meter cube is 1000 liters. So 108 meter cube will be 108 into 1000, that will be 108,000 liters. Now, question given to us is 60 liters take 1 minute to fill. So 108,000 will take how many minutes? So if you cross multiply, you will get 108,000 into 1 upon 60. 0 and 0 will get cut. 6 ones are 6, 4 8, 6 8s are 48. So 1800 minutes, because we are comparing the minutes. We had 60 liters, this was liters, and this was minutes. So by comparing we got 1800 minutes. But the question they have asked is find the number of hours. So we'll convert this minute into hours. How do you convert minute into hours? To convert hours into minutes, you multiply by 60. So to convert minute into hours, you will divide by 60. So 0 0 cut, 6 ones are 6 30s are. So the minute becomes hours. So it will take 30 hours for the whole reservoir to fill if water is pumped at 60 liters per minute. So this is the end of the exercise. I hope you enjoyed the sums. They are very simple. You have compared the answers with mine. Now do the necessary corrections wherever needed. And for the homework, you have to do this exercise in your fair book. So this exercise is done. Now very shortly I am going to take a live lecture on either Google Meet or Zoom, where we will discuss the answers and solve your doubts. So I'm going to end for today and the chapter is over. What you have to do is, first of all, revise all the formulae. We have only taken three shapes in this chapter. We have taken the cuboid, the cube and the cylinder. We learned to find out the curved surface area or the lateral surface area, the total surface area and the volume of these three-dimensional shapes. And we also found out the area of the parallelogram, the rhombus and the trapezium. So here I end the chapter. Thank you.